SAP helps the world run better and improve people's lives. We are the market leader in enterprise application software, helping companies of all sizes run at their best. The solution we are using today is SAP Analytics Cloud. The SAP Analytics Cloud helps all types of decision makers by combining business intelligence, enterprise planning, and augmented analytics in a single solution. Rather than relying on separate, disconnected spreadsheets, reporting, and planning tools, everyone has everything they need embedded where they work to make faster, confident decisions together. This complete solution, in addition to allowing you to make end-to-end decisions, gives the contextual information within your business process, allowing you to take action on the insights. And you can do so with confidence from smarter decisions driven by AI and machine learning delivered to all users. SAP Analytics solutions are being used in 25 different industries today, including healthcare. We also host and promote a number of health-oriented social initiatives, including the 1 Billion Lives program. The aim of SAP 1 Billion Lives is to help solve the world's biggest social problems by bringing together the best the company has to offer, its people, technology, data assets, and vast ecosystem. We have consulted and worked with the doctors and experts in these initiatives to make sure that what we are sharing with you is both technically sound and socially responsible. We consider the possibility of altering our presentation to have a COVID-19 slant. In reviewing the data, we found that there is already a strong link here. The data insights we found point to scenarios focusing on underlying conditions, which we have all learned have a significant impact on who gets the virus, how badly they might suffer, and the chances of survivability. To that end, we have maintained our original scope and focus with the original data set. Here's our SAP Analytics Cloud story. In the upper left, we have life expectancy in the top 15 countries by absolute value. We also can see percentage variance in the gains that have been made in the last 20 years. Japan is the highest, but the US is in the top 10. Now, if we look at healthy life expectancy, we can see healthy life expectancy has not gained as much. So while we are getting older, we are not necessarily living healthier. We will continue to examine this. But first, let's let the system do some work for us and use Smart Discovery to see our key influencers. This allows us to see the main categories of influencers, environmental ones such as unsafe water, and personal lifestyle ones like obesity. If we hover, we can see other influencing factors. Smart Discovery shows us key influencers, and it also allows us to take a deeper look at the other influences. Now let's look at the next chart and we see infant mortality. It's nice to see it's greatly improved. If we focus on under 5, we can see a concerning number in the US with over 50,000. By using Smart Insight, however, in real time, the system can determine the top contributors. And in this case, it shows us that neonatal issues deserve greater analysis. If we go back, we can also use linked analysis to see trends over time. For instance, with HIV, we can see the dramatic improvements that have been made. All good news. Now, based on the Smart Discovery insights from before, we can look at top influencers, like lifestyle factors and obesity. Here we see that the US is number 3. But if I make this personal and look at male BMI, I can see the US is the highest. We can also look at the environmental factors we found and be grateful to see the declining influence, reinforcing the idea that personal lifestyle is worth more analysis. Other things to notice are that with linked analysis, we can change a measure and it's reflected elsewhere. We can also use a tree map to see the relationship in data, in this case, the financial impact on life expectancy. We have Smart Insight here too, with the system telling us the US is spending 300% above average. We can also get details by hovering, so we can see the US and compare it to Japan. And if we filter on the US, we can see the link chart showing a flat curve on life expectancy. This indicates diminishing returns on spending. Some solutions may be social and not medical. Finally, we can examine the data in table form and examine the spending and sort columns by regions or rows like life expectancy to see the data we want, all within the same SAP Analytics Cloud. So how was it made? We'll create a blank page and then we'll choose a template for the layout. We'll select to add a chart and selecting life expectancy as a measure and country as dimension. We'll do a second chart with death of children under 5 and country as dimension. Now we add an input control. For dimensions, we'll select year as the filter, and then we'll make it a single selection. Since we now have a single year displayed, we can go to the first chart and have it automatically add the previous year for comparison. At any time, we can explore the underlying data on these charts. We can view all the dimensions, change them, or any of the measures, so we can see and do deeper analysis on the data. Now, the machine learning key influencers we showed earlier were generated by the system. It automatically created a histogram to show the distribution of life expectancy data and other analysis. The next page the system created was key influencers. This shows the top 10 influencers, and the detailed chart below show how they relate to each other. In addition, we use Smart Predict to create a sophisticated forecast, and we restricted to only using those top 10 influencers. While life expectancy overall rises, we notice that in developed countries, when we're focused on those factors, they are continuing to decrease in life expectancy. This is the insight we talked about previously. We can also examine the detailed information behind these predictions to give us confidence in them. Now, going back to building, we can add life expectancy at birth and year. It only shows 1 year because we have the input control limiting us to a year. But we can tell the chart to ignore that and see all the time. We also can see the scope of the time, so we can change it to make it easier to display. And finally, we can have the system add an automatic forecast. Finally, create a table. We'll arrange our rows and columns. And since we want to have a new calculated dimension, I'll show here, as it's been already created, what it looks like. And here we see the groupings that are based on the measures. Finally, we'll add the measure we want to compare it to, which in this case is GDP per capita. For data prep, first we'll create a model, then we'll acquire some data. Once we have that data, we'll delete that duplicate header row. The system has automatically done data quality analysis for us and allows you to select the bad data. We can then see that it's a date range instead of a date, so we can transform that data, in this case split the ranges at the dash. Then we let the system know to treat this as a date field. It automatically recognizes it as a year. Now let's remove that extra column. We can also enhance other columns like the GHO column with dimension attribute linking. Finally, we can clean up it more by removing any unneeded columns. And to make it easier to read, change the label on the year column. We can also have the system automatically remove duplicate rows. Now let's link our combined data. We select our new data source, the happiness index. We define how we want it to join. In this case, we're combined on year and then country. As we do this, the preview shows us how the join affects the data. Once it's done, the system will run a validation as it combines the data. And once we're happy with that, we can tell the system to go ahead and generate the model. Once the model is generated, let's go create a story on that data set. We create a story and then select the model we just created. We enlarge our canvas to make it easier to use. Now we select our chart structure, select dimensions, including the enhanced dimension we modified GHO. We can then add filters on that. Now we can select more dimensions. Then we add a measure. Now we can drill down on the dimensions. Or we can continue to add measures from our combined data set. We can split the y-axis, and then we can have the system create an automatic previous year comparison. The easiest way to share the information is to go into the story, share, then schedule the publication. Once we have that, we can add a nice subject and even a message. We then decide when we want to send it. After that, we can decide if we want this to be a reoccurring schedule and determine how long it will continue. Now we need to tell it who to send it to. In this case, we're going to use an internal user of the SAP Analytics Cloud system, but we can also use external users. I then can determine any settings I want, such as to send all the pages or a page range, or in this case, I want to include an appendix. This will tell the system to go ahead and schedule, and we wait. Now this email is generated, and in there it includes a file and also a link back to the original report. We can go through and see that all the pages are here. And we can see it includes the appendix we asked for earlier. This appendix includes information about the details in the charts. This is to give the user more context without them having to go back to the original system to find out. On the left, you see the SAP Analytics Cloud value driver tree. This allows us to visualize the data and how it influences each other using a sophisticated planning what-if model. The tree is created on those key influencing factors that Smart Discovery identified earlier and is organized into 4 categories: finance, public health, personal health, and environment. As we determined earlier, personal health factors are important. So let's see how a change impacts. In this case, we can manually modify a factor to see its impact on overall life expectancy. Here, I'll see a reduction in diabetes-related deaths and see how it flows through. But that was just my guess on what to modify. We can also leverage the power of the group by having them interact. By pointing a phone at the QR code, the audience can in real time vote on the outcome they would like to influence. In this case, they've selected alcohol. After voting is complete, I can publish results and see the values will be modeled into the data set and a new scenario generated with a new result. This allows SAP Analytics Cloud to leverage our planning, what-if analytics, and external group workflow inputs to give even deeper analysis and more insight.